This presentation will evaluate the differences in trimmer technologies with particular attention on high-precision applications. Foil trimmer materials, internal design and construction all contribute to provide in-circuit performance advantages that can translate into a superior design. A trimming potentiometer is a mechanically driven, usually by hand, variable resistor used to trim resistance in an initial circuit or to adjust the circuit for drift characteristics after load life, shock, thermal shock, or some other circuit-changing experience. When used as a variable resistor, it is called a rheostat, and when used as an adjustable voltage device, it is called a potentiometer. They can be used in general-purpose, non-critical applications as well as in precision applications. The end application determines which type of trimmer is most appropriate. Trimmers are generally linear devices, but in the potentiometric mode, they may be function pots such as sine and cosine functions. Vishay bulk metal foil trimmers are recommended for use only in precision applications. 4 overall categories of concern are generally considered for the selection of the trimmer: mechanical, electrical, operational, and economic. While some of these may be interrelated, it is generally the operational characteristics which are of paramount concern and are also the most elusive in high-precision applications. Consequently, this presentation will concentrate mostly on operational characteristics and to some extent the technological factors which affect them. Trimmers are mechanically driven variable resistors. To alter the value, a wiper is moved across the resistance element, picking off an intermediate voltage in the potentiometer mode or adding resistance in the rheostat mode. Some models employ a lead screw while others a drive gear. All models have a clutch at either end of travel to avoid mechanical damage. These mechanical aspects have caused some users to avoid designing with trimmers and are of special concern when selecting trimmers for precision applications. This presentation will describe the various types of trimmers available and how the selection of foil-based trimmers compensates for the deficiency of other types. Circuit tuning has long been a requirement that calls for some sort of adjustable device, and while there are adjustable capacitors and inductors, the industry has relied primarily on adjustable resistors or trimming potentiometers because of their availability and breadth of values. But the level of reliability and performance has not been equal to the industry demand, which has led to a decline in usage, and in some applications there is an outright prohibition of their use. The main reason for the prohibition is the many moving parts in a trimmer, which affects in a major way its stability. Motion of the wiper due to vibration, for example. In a particular application environment, shock or vibration can cause the resistance value to change. In these demanding applications, the Vishay Accutrim bulk metal foil trimming resistors overcome the deficiencies of some other devices and become the product of choice. Furthermore, wire wound and Surmet trimmers have restriction due to resolution, settability, TCR through the wiper, etc. The most commonly used trimmer technologies, wire wound and Surmet, were designed many years ago and have not really seen substantial positive changes in design, construction, or performance. The recent introduction of the Vishay bulk metal foil trimmer, however, offers the designer a device with significant performance improvements. These new bulk metal foil-based trimmers not only overcome the electrical concerns from the past, but have been designed to be unassailable mechanically. Consider these problems seen in the past: moisture ingression, adjustment screw ratio and backlash, and wiper noise. We'll examine each of these in turn. At one time, all trimmers were O-ring sealed around the lead screw, but cost pressures resulted in the use of Lambert seals. After several adjustments, the Lambert seal integrity can be brought into question. To overcome this and to get through the first board cleaning process, certain temporary sealing methods were suggested. These were often rejected, for example, by the military industry, and this was one reason for reduced usage. In contrast, Vishay continues to use a much more reliable O-ring seals as the safest protection against the ingression of moisture and performs a 100% seal test on all products during manufacturing. The number of turns that a screw has available for adjustment directly affects the possible accuracy of the adjustment. Some trimmers have a coarse thread of only 12 turns end to end, while the Vishay foil-based trimmers have 26 turns. This gives the foil-based trimmer a higher degree of settability. At one time, all trimmers had the lead screw spring loaded in the housing, But here again, the pressure to reduce device costs drove the industry to drop the tensioning spring. Here again, Vishay continues to tension the lead screw so that backlash is minimized and the product has a higher order of setting stability. All trimmers introduce noise as the wiper traverses the resistance element. This is a real problem when trying to fine-tune an instrument. Compared to a Surmet trimmer, the contact resistance variation is much closer to nominal across the full range of wiper travel. Trimmers made with wire-wound elements were the original trimmers. They have a relatively good end-to-end temperature coefficient of resistance, but are limited in resistance range and display a step function output that is particularly problematic in the lower resistance values. The TCR through the wiper is also not good. In wire-wound trimmers, noise comes from the single point contact of a wiper engaging each turn of wire. To improve specified performance, the industry calls for the CRV to be measured after several passes of the wiper, and thus the oxide in the wire breaks down and the noise level eventually improves. That is why the industry insists on several passes before determining noise. But what if the user wants to do it with a single adjustment? However, it does cause a technician to implement a process of several passes after installation of the trimmer. Due to the single point contact, the wiper can only touch the wire at one point. The contact is thus susceptible to debris and other causes of noise, in addition to wire oxidation. There is another phenomenon, skip turns. The wire does not always have the same profile turn to turn, so the wiper can sometimes skip turns as it moves along the element. This is a linearity issue, adjustability, and a repeatability issue. Loose wire turns can relocate. Surmet trimmers made of screen and fired inks extended the range of resistance values over those of wire wounds, and have introduced the claim of infinite resolution. However, users have learned that the curved trace is not a smooth and unidirectional change of resistance, and the end-to-end TCR is 100 to 300 ppm per degree C, with a TCR through the wiper of 1000 to 5000 ppm per degree C. This is usually not shown in detailed specifications, but is essential knowledge in rheostat applications. Surmet trimmers have a high end noise ratio as the wiper shoe waddles up the resistance element. Contact resistance variation, CRV. In Surmet trimmers, a carbon shoe moves up and down the element, creating and gathering debris. The contact is sometimes at the front of the shoe and sometimes at the back of the shoe. This action is a source of noise, 1000 ppm per degree C, but also a source of nonlinearity. A user attempting to adjust a circuit with a Surmet trimmer will sometimes find that the rotation of the screw in one direction is suddenly the wrong direction for the intended adjustment. Mechanical construction. Surmet trimmers are designed and manufactured to minimize costs rather than provide accurate and robust performance for the user. As a result, they use the least expensive materials and during their evolution have compromised some design considerations, which can mean limited performance in terms of temperature and vibration sensitivity. The Vishay foil trimmer has a flat, cold rolled foil element with smooth and unidirectional infinite resolution adjustment for lower ohmic values and somewhat lesser resolution for values 5K ohm and above. The foil trimmer also achieves a very low TCR end-to-end, 5 ppm per degree C, and a TCR through the wiper is 25 ppm per degree C. Further, the contact resistance variation is now reduced through the use of a multi-fingered wiper on a planar surface. Finally, the unique element resistive pattern design minimizes the capacitive and inductive reactance levels. Due to these performance advantages, it provides an excellent choice of trimmer where very precise adjustment is necessary. Most trimmers are built with thermoplastic materials which can soften and deform when exposed to high temperatures. This is needed to make the Lambeth seals work. By contrast, foil-based trimmers are made using dialethylate, which is a thermoset material with substantial stability under temperature. The increased stability makes the foil trimmer a preferred choice in extreme environments such as downhole and other high-temperature applications. This graphic displays the output to be expected from each of the three major trimmer technologies. Notice that the wire wound trimmer provides a step function result, with each step increase being the resistance of a single turn of wire on the wound mandrel. The wiper bumps along from one turn to the next, making an intervening adjustment impossible. This is a major problem when the user is working at low ohmic values. The Surmet trimmer, on the other hand, displays a somewhat erratic output, meaning the user can see both increases and decreases while turning the screw in the same direction. The foil trimmer gives a smooth and unidirectional output with each turn of the screw, and while it's not a perfectly straight line, it is much more consistent than the other two technologies shown. Temperature coefficient of resistance, TCR end-to-end. The TCR of foil resistors is the best in the industry at 5 ppm per degree C, while typically a wire wound trimmer is 50 ppm per degree C and a Surmet device is about 300 ppm per degree C. TCR through the wiper. It is unlikely the specification will be highlighted in most trimmer data sheets. The reason is that it is a function of contact resistance, wiper movement, and the TCR of the element itself. All variable and unpredictable in other technologies, but the foil trimmer with its high-performance design of a multi-fingered precious metal wiper making multiple contacts with the flat resistive element means TCR through the wiper can be specified 25 ppm per degree C. This result is even better than the TCR end-to-end of other technologies. Tests have shown that through the wiper TCR for Surmet trimmers is plus or minus 1000 ppm degree C or worse, and for wire wound trimmers it is 100 to 500 ppm per degree C depending on the resolution of the trimmer. A low TCR through the wiper value is essential for rheostat applications. Some users are accustomed to improving the output linearity by paralleling the trimmer with another resistor as in figure 5 of this chart. The cost of the two additional resistors, or one additional depending on the case, by themselves are not much, but the installation cost and the loss of board space could be a more important factor. Taking advantage of the foil technology, a low-valued foil trimmer in series with a high-valued fixed resistor, preferably a foil resistor, is shown in figure 6 and is the best trade-off of cost to performance. This way, the selection of a high-valued Surmet trimmer can be a source of noise, instability, and a high TCR change. In applications requiring precision, the cost advantage may not be worth the performance risk. There is also the board space and the insertion cost savings of using fewer components. Inductance. Fish-shaped bulk metal foil trimmers have a very low inductance of about 0.08 microhenries. Wire wound trimmers are notoriously inductive. Accuracy. Fish-shaped foil trimmers are the most accurate end-to-end, around 5%. The end terminations are welded contacts precisely placed as opposed to the uncertain solder connections in wire wounds or pressure contacts in Surmets. Rotational life. Fish-shaped foil trimmers withstand the most number of wiper excursions because of the multi-fingered wiper. It will perform at least 1,000 cycles. When used in a circuit, the trimmer will self-heat, and in Surmet trimmers this can result in significant change in resistance value. Foil trimmers, as can be seen, are much more stable. The foil-based trimmers are more expensive, but it is well worth the difference if the circuit suffers from any of the disadvantages of a cheaper device. Cost calculations should include not just the purchase price, but the technician time to adjust the circuit to value initially and then readjust cost if the instrument is jarred and has to be brought back in for calibration or replacement. Foil trimmers offer the best level of precision, TCR, stability, etc., and rugged service. In addition, Surmet and wire wound trimmers use two additional resistors. The Vishay bulk metal foil trimmer is the best performing device in all categories. The foil trimmer has a multi-fingered, noble metal wiper engaging a planar surface of etched foil. A selection of styles is available. Samples and technical support are available. Foil trimmers are particularly good for low-value resistance in series with higher-value resistors to be adjusted. TCR end-to-end 5 ppm per degree C at least 20 times better than Surmet. TCR through the wiper 25 ppm per degree C at least 50 times better than Surmet. Resistance values as low as 2 ohms. A summary table of comparisons is shown here. It highlights the many advantages for precision, high temperature, and high vibration applications discussed in this presentation. As has been stated, the specified parameter may not be the only advantage. Avoiding additional or future adjustments by technicians and more reliable stability of performance are other benefits. For more information about our complete line of bulk metal floor resistors, please visit our website.